Today we're gonna talk about chemical bond. When I read high school books that they talk about chemical bond, I found out that they are so regular and diffused. And I know that students need a method and document that all of the chemical bond be in a one slide. Okay, it's time to do it with a complete description just in one slide. Let's do it. As you see, chemical bond divides two parts: atomic bond and intermolecular bond. Atomic bond individually divides to three parts: ionic bond, covalent bond, and metallic bond. Metallic bond doesn't exist in the high school books, but I give you a brief description about that to know all of the chemical bond. Then we see the intermolecular bond, and as it's obvious from its name, it's about the attraction between two molecules. At first, let's talk about the ionic bond. I have to tell you something that it might be unusual for you, but at the end you'll find it that it is so useful. For atomic bond, don't forget number 8. You know why? Because noble gases end up their last shell with 8. But why noble gases are so important? Because the noble gases are the most stable elements in the periodic table, and all of elements prefer to be stable like noble gas. So the number 8 comes from the noble gas. For example, ionic bonds are the salt, or the bonds between a metal and a non-metal, or the ionic bonds are the bonds between two elements that they have great electronegativity difference. Why? Ionic bonds are bonds that talk about the transfer of electron from a metal to a non-metal. For example, imagine NaF, or sodium fluorine. When we wanna attach them to each other, sodium will lose its valence electron, or the electron in its last shell, and fluorine accept it, so the electron will transfer from the sodium to fluorine. And as you see, the last one of both of them turns to 8 electron. As sodium loses 1 electron, its last shell turns to 8 electron, and fluorine, as it gets 1 electron, its last shell will turn to 8 electron too, because it had 7 electrons before this electron. As you see, number 8 is so important in atomic bond. And as sodium loses 1 electron, turns to ion with 1 positive charge, and fluorine turns to an ion with 1 negative charge. As we know, ion with positive charge are cation, and with negative charge are anion. So fluorine in here is anion, and sodium is cation. So since here we find that in ionic bond, electron transfer from one element to another element, and the electronegativity difference between these two elements is so great. And another thing that you find that ionic bond is it's usually occur between a metal and non-metal. Ionic bonds are so tough, like salt, but they are fragile, because when you kick an ionic bond, the electrons that are so regular in that material will lose their regulation, and two negative charge or two positive charge will be put together, and they want to escape from each other, and the material will be cracked. Now let's talk about the covalent bond. Covalent bond is about sharing electron between two elements. As we know, ionic bond is about transferring electron, but in covalent bond, two elements will share their electron, and it's usually attached two non-metal elements to each other, and the electron negativity difference between the elements in covalent electron is lower than ionic bond. For example, imagine H2 that is contained of two hydrogen. When you put two hydrogen atoms next to each other, as hydrogen has only 1 electron, both of them share their electron to each other, and covalent bonds will arise because hydrogen is non-metal, and as I said, the covalent bond occur between two non-metal usually. Covalent bond divide to two parts: polar covalent and non-polar covalent. covalent. It's obvious from their name, polar covalent will occur when we have two elements or two non-metal elements that they are different. Non-polar covalents are occur when the both of the elements are same. For example, like H2 or O2 or N2, because the atoms have the equal attraction for electrons, so the sharing is equal. But for the polar covalent, the distribution of electron between the two elements is unequal. For example, imagine OH. As we know, hydrogen has a lower electronegativity compared with oxygen. So oxygen will take most of the electron toward itself, and the cloud of electron around the oxygen is bigger than hydrogen. But I have to tell you something that I think you will like it about the covalent bond. Most of the covalent bond will lead to molecule. To say it better, molecules are linked to covalent material, and the elements that their bond are covalent, most of the time they will create molecule, something like water. If you draw the water structure as it is H2O, there are two hydrogen that attach to one oxygen. So the bond between oxygen and hydrogen is a covalent bond because they attach two non-metal elements to each other. And it is a polar covalent because oxygen and hydrogen are different. But what is the energy that attach two water molecules to each other? It is an intermolecular bond that attach these two molecules. For example, when we have two H2O, an oxygen from a molecule will attach to hydrogen to another molecule. And this story will continue till we see an ocean of water. Intermolecular bond can attach two polar molecule or two non-polar molecule or one polar to a non-polar. For example, when we talk about the H2, it is a non-polar molecule. So when we wanna attach two H to each other, the bond that attach then connect these two H2 is a non-polar molecular bond. On the other hand, the bond between two molecular water is a polar bond because both of molecules are polar. I will talk about the polar molecular more when I talk about Lewis structure, and you will find it so better on that list. As I told you, I promise to give you a brief description about the metallic bond. It is something like covalent bond. Imagine an ocean of electrons that the positive charge attract them toward itself. So it will arise something like iron. And as I said, the ocean of electrons wouldn't be cracked. Just the positive charge will transfer another place when you kick the metallic material. It was a story about the chemical bond. And as I promised you, I bring all of them in one place. I hope you enjoyed kind of teaching. Good luck.